Alright, so this is the Hess Law Project by Carter and Christopher. So our initial equation is B2H6 plus 6Cl2 yields 2BCl3 plus 6HCl. Our first equation that we're given is BCl3 plus 3H2O yields H3BO3 plus HCl. 3HCl, pardon me. With a change of heat of negative 112.5. Next equation that we have is B2H6 plus 6H2O yields 2H3BO3 plus 6H2, and the change of heat equation for that is negative 493.4. Our last equation is 1 half H2 plus 1 half Cl yields HCl, and the change of heat on that is negative 92.3. So we notice that the variables, or the parts of the equation that we want here, are the BCl3 for this one, which is lined up with the BCl3 for the product in our initial equation, which means we're going to have to flip it to the other side by multiplying this by a negative and this by a negative. And then we're going to have to multiply that by 2 to get the moles aligned. Next equation, we see that we've got a B2H6 here in the reactant, and a B2H6 here in the reactant on our initial equation as well. So we're going to want those to be matched up. And fortunately for us, they're on the same side and their moles are the same. So we're not going to be multiplying this equation by anything. We're just going to leave it the way it is. Our next step, we notice that this one's got a Cl, which is helpful for us because we have a Cl here, and they're both in the reactant. But our main focus is this, the HCl. There's an HCl on the product, and this is the product as well. However, the quantity of moles are different, so we're going to be multiplying that by 12. So then we have our multiplying here, which I said before, this is a negative 2, and this is a 1, and this is a 12. So they line up with each of these equations. You're multiplying the whole thing, except for this middle one. It's staying the same because that's exactly how we want it. That means that these three equations are correct, and we can check them off. Moving on, we have our equations after we've done all that multiplication and gotten them simple. We have 2H3BO3 plus 6HCl yields 2BCl3 plus 6H2O. Change of heat, 225. Then we have B2H6 plus 6H2O yields 2H3BO3 plus 6H2. And the change of heat on that one is negative 493.4. Well, our last equation is 6H2 plus 6Cl2 yields 12HCl with a change of heat of negative 1107.6. The next step for this is to add up all of the products and make it yield all of the reactants. So to do that, we're going to begin. So we have our 2H3BO3 here, our 6HCl here, our B2H6 here, our 6H2O here, our 6H2 here, and our 6Cl2 here. Then we have our products. So our 2BCl3 there, our 6H2O there, our 2H3BO3 there, our 6H2 there, and our 12HCl there. So then we begin canceling. We have a 2H3BO3 here, and we can cancel that with this one right here. We have a 2HCl right here, or 6HCl here, my bad. And that can cancel with this 12HCl to get 6HCl, which is exactly what we want for this master equation. Then we have a 6H2O, which cancels with this 6H2O. A 6H2, which cancels with this 6H2. That's it. So we have our remaining reactants are the B2H6, which go there, and the 6Cl2, which goes right there. I know you can't see it, but that's where it is. And then our products are the 2BCl3, which is right there, and the 6HCl, which is right there. That brings us to final change of heat equations of negative 1107.6, negative 493.4, and 225. Add those all up, and you get negative 1,376, which is what we were trying to find from the beginning. And then our equation is B2H6 plus CCl2 yields 2BCl3 plus 6HCl, which is exactly the equation that we had to begin right here. Thank you for watching.